first of all, I will say that I'm going to introduce the graphing just by taking an x and solving for y, because I don't want you to ever forget that that's an option for functions themselves. But we are going to go through some shortcuts on graphing these, so I'm not really going to have you do a bunch of like just pick x's and solve. But just to remind you, this is a function. So if you have an x, you can get a y by just plugging it in. I feel like sometimes we get too far past the process and we forget that step here. And so they've given us these 3 points. They've given us the points for our x. They've given us the points 1, 2. They've actually given us 4 points. And so if you were to plug those in for x, we would get -1/2 plus 2, so we would get 1.5 here. Plug in a 2, we would get -1/2 times 4 plus 2, so that would actually give us a -2 plus 2, which is 0. Plug in a 3, we're going to get a -9/2 plus 2, so we would get something like that. And plug in a 4, we get -1/2 times 16, which would give us a -6 here. And so if you have this parabola, you could pick these 4 points. And they happen to actually give us our vertex when they picked these particular points. And so they gave us, let's see, 2 was there, 1, 0, 2 was 1.5. What happens here is we have this going on. We have 3, let's see, what was 2? 2 is 0. You can kind of see what's going on here. The problem here is that you don't know for sure that that's the turning point. You can kind of see it is, but what if it weren't? And so if you just are picking x's and you don't happen to pick one that is on both sides of your vertex, then you may not realize where it's going to turn, okay? And so when you sketch one of these, it's better to go through what we're about to go through versus just picking x and y's. Because even in like an absolute value, when you have an absolute value, if you don't recognize how to find the vertex of the absolute value, if you just pick 3 points, you may think you're graphing a line if you pick all of them on one side of the vertex. And so that can happen with the parabola as well. You may not see the shape of the parabola because you do not see the vertex and the axis of symmetry. And so if you look at page 242, there are shortcuts to graphing these. So if you have this graph in standard form, some things will always be true. Just like if you have a slope of a graph in slope-intercept form, you can pick the variable x, and the number right in front of your coefficient of x is always going to be your slope. So when it's in standard form, you always have certain things that are true. The first thing is we can look at the A. The A here tells us something about how it's graphed. If A is positive, the parabola opens up, meaning it is like cone-shaped up, concave up. If A is negative, the parabola opens down. It's concave down, looks like an upside-down bowl, okay? And so the very first thing we can look at is our A. Positive is going to be up, negative it's going to be down. The next thing is we can find our axis of symmetry using these coefficients as well. The axis of symmetry will always be -b over 2a. You do need to remember that, okay? -b over 2a. -b over 2a will be our axis of symmetry. That is also the x-coordinate of my vertex. All right, the x-coordinate of my vertex. If I have the x of a point, how do I find the y? You plug it in. And so once you find the axis of symmetry, you have found not only the axis, you have found the x value of your vertex, and you take that and plug it into your function to get the y value of your vertex. So your vertex ends up being an x value of -b over 2a and a y value of f of -b over 2a. You plug it in. The last thing is your c. Your y-intercept will always be 0c, because your y-intercept is when you plug a 0 in for x. Well, you have an x squared plus an x. Those are both going to 0 out. It leaves just the c. And so when you have it in standard form, you automatically know your y-intercept. And so you can graph your vertex using your -b over 2a, your axis of symmetry using the same thing, and then you can plot your y-intercept. And if you know your y-intercept, you know it is going to be symmetric to this line. You can walk across that line and plot a symmetric point. And then you have your vertex, 2 symmetric points. You know which way it goes, whether it's going up or down, and you can sketch the graph of that parabola, all right, by using those shortcuts. Now, if for some reason it happens, your graph, the axis of symmetry, is the y-axis, you're not going to be able to use your y-intercept because it will be your vertex, okay? So you will have to pick another point to mirror to see where you're going to go on it. But that's the only situation that you cannot mirror that y-intercept, is if it happens to fall on the axis itself. So let's do some of these. Look at example 2. Graph this, label the vertex and the axis of symmetry. I'm actually going to have you list them. So I'm going to say, list your vertex, your axis of symmetry, and your y-intercept, and then graph. So I'm actually going to have you give me all of those things and then also graph. So the first thing we're going to do is we are going to find our axis of symmetry. Now, question, does this point up or down? Up. My A is a positive 1, so this parabola is going to be pointing up. All right, so my axis of symmetry is going to be negative B. My B is negative 2, so negative B over 2 times A. My A is 1. So we are going to use my A, which is 1, my B, and my C to do all of this. So negative B over 2A. So that is going to be positive 2 over 2, which is 1. So that means my axis of symmetry is 1. So I'm actually going to go to a positive 1, and I am going to draw my vertical line that is dashed. It's not actually a part of the graph. It just helps me graph it. All right? So this just helps me graph it. I should construct or draw my axis of symmetry there. All right? That also gave me the x value of my vertex. So next we're going to find our vertex. So to find this, we're going to take the 1. So we automatically know that it's going to be 1 something. We're going to take the 1 and we're going to plug it in. 1 squared minus 2 times 1 minus 3, right? So I have 1 minus 2 minus 3. I get what? Negative 4. So my vertex is 1, negative 4. So I'm going to go to my graph, 1, negative 4, and I'm going to plot my point there. 1, negative 4. All right? And then the last thing I'm going to find is my y-intercept. My y-intercept is really easy. It's going to be the point 0 and then my C value, which is negative 3. And so I go to 0, negative 3, and I'm going to plot that point there. I know that if I have that point, it should mirror across. So this negative 3 is 1 away from my axis of symmetry, so I can go 1 on the other side and plot a point there as well. And then I can just sketch this graph, all right? Which should look something like this. And so I found those 3 points that are 3 things that I need to help me sketch it, and then I'm going to sketch it, all right? They can just say graph it. They can say find the minimum value, right? Find the minimum value. And if the function that they have given you is a quadratic, your minimum will always appear at your vertex, right? If they say find the maximum value and they give you a quadratic, the only way you'll have a maximum is if you have a quadratic pointing down. So they could say find the minimum value. What they're saying is find the vertex. They're not actually saying vertex, but that's what it means if they say find the minimum value. In the word problem, if you look over at the word problem, it says the number of items a company sells is frequently a function. They've given us the function, all right? And this guy is a, looks like a linear equation, but then you multiply it by your product price times the number sold, and you end up with an equation that looks like this. And usually they won't make you calculate it, by the way, but they end up with an equation that looks like this. This is a quadratic, and it says what price will maximize the company's revenue? What is the maximum price? They're asking for the XY value of the vertex, all right? So if they're telling you what these variables represent, in this case are price is your X value of your vertex, revenue is your Y value of your vertex. So when they say what's the maximum that's going to happen, they're literally just saying find the vertex, okay? And so in a word problem with a quadratic, they're going to use the word find the maximum, find the minimum, and what they're actually telling you is we want the vertex, all right? Because that's where it will always happen. So you're still going to do negative b over 2a and f of negative b over 2a to give those values. You're still doing the same thing. You're just not having to graph it. You're just answering the vertex question by the words maximum and minimum. Make sense?